Okay, so we're starting with trig. And in trigonometry, what we're going to be doing is simple triangles. The word tri is triangles, and we're looking at the angles and sides of triangles. So let's start from the foundation, what you need to know to survive. If we look at the XY axis, we have an X axis and we have an Y axis. So if you take any point that I'm referencing here with my mouse, we can call it XY. And what you can do is quickly form a triangle. And when you form a triangle, your side from, I think I need me right here, just to make it clear. So we know this is the X value, and this is the Y value, and we have an R, which is your radius. So we all know we can use Pythagoras to find a side, condition we're given two sides. So that's our starting point. Now, I know you studied three ratios. The first ratio we refer to is sine. What does sine mean to us? Sine is basically a ratio, which is a fraction, meaning y over r. You need to know the definition. Sine is y over r. You can memorize that if you don't know that. Cos is x over r. And tan is y over x. Now, there's no such thing as sine, cos, and tan. It's sine of an angle. So I must say sine theta, because we're looking from this angle here. So that's our basic definitions: sine, cos, and tan. And there is a mnemonic that you would have learned how to remember that. Shield your rear, cos x rays, tan your exterior, which means S for sine, which means y over r, C for cos, x over r, T for tan, y over x. Not necessary to remember the mnemonic, but it does help when you're confused. So coming into a triangle, if we're not on the Cartesian plane, this is very handy to know. So if we look at this triangle, and if we look at theta, the side opposite theta, we're going to call opposite. And the side next to theta, we call an adjacent side. And remember that your radius is always opposite the right angle, which we can call the hypotenuse. So if we're not sitting on an XY Cartesian plane, it's good to know a famous mnemonic that I give my math students. Sounds like Chinese. So ka tua, which basically means S for sine, which is equal to opposite over hypotenuse. C for cos, which means adjacent over hypotenuse. T for tan, which represents opposite over adjacent. So remember, so ka tua. We are going to use this a little later on. So we have two options. So the question is, when do we use so ka tua? If we're sitting with a right angle triangle, not in a Cartesian plane, very handy to use so ka tua. If we're in a Cartesian plane, then we would like to use y over r, x over r, and y over x. Okay, let's look at our first question we have. So in this question, they want us to find GH, correct to one decimal place. So in order for me to do that, I want to first get the ratios in terms of which is the opposite hypotenuse and adjacent. Now remember, I'm not in the XY Cartesian plane. So I'm going to use my ratios called so. I know if you're doing science, it's very handy. So for all the science students to know this as well. Okay, I just want to admit more people in here. Okay, so we have our so ka tua. But if we look at the diagram, they want us to find GH. Now, GH in reference in this diagram, GH will be the side opposite the 90 degrees we call the hypotenuse. And now I'm looking from an angle called 69. And if I look at from 69, the 7.1 is actually the adjacent side. So we're going to call it A. And opposite 69, FH is actually the opposite side. But the question is to find GH. So if I'm going to find GH, I have to use H, which is your hypotenuse. And I'm not going to use O because the adjacent side is given. So we're going to use adjacent and the hypotenuse. Adjacent because it's given, hypotenuse because it's that's the question. So I just want to go back. If we look at this ratio now, which ratio has an A and an H? So we look on the top, so car. Immediately we see cos. So if we write down what is cos theta, cos theta would have been adjacent over hypotenuse. But we know the angle is 69. So we're going to replace that theta with 69. So we can say now, and I'm going to start here, that cos 69 is equal to, we said adjacent over hypotenuse. So remember your adjacent is 7.1 on the diagram, and your hypotenuse is what we want to find. So we will call it GH. So the quick way So what I want to do next, when I'm looking at my diagram, I'm going to put this over 1, and then I'm going to cross multiply. So we're going to end up with GH cos 69 is equal to 7.1 times 1, which is 7.1. And to find GH, we got to divide by cos 69 on both sides, because whatever you do on the left, you're going to do on your right. So we have that canceling off. And can someone take out a calculator and type that in for me for GH? I'm getting 19.8. Can we have someone confirm that?
Yes, sir.
All right. So that is an application of using SOHCAHTOA in a right angle triangle. So we're going to go to a more complicated question. And we're going to look at how do we actually, and this is an exam type question where they would combine the diagrams for you. So very important to note for a maths paper 2. Apparently maths paper 1 was very easy according to the critics. So expect a little bit of a challenge in maths paper 2. Now, the question here is to calculate M. Now remember, we can only use SOHCAHTOA, in other words, sine, cos, and tan in a right angle triangle. If it's not a right angle triangle, we can't use our SOHCAHTOA. So if I look at this diagram, the question is to find M. So what I'm going to do here now is I'm going to now highlight the triangle that has M in it, a right angle triangle. And if I highlight that red triangle, remember my focus is to find M. There is my right angle. So we want to find which ratio should I use. So I'm going to write it down. SOHCAHTOA. We only need to use one. And it's going to be depending on what's given in the diagram. So if we look at the red triangle, 6.3 is given. 18.7 is the given angle. So our reference angle that we normally would have called theta is sitting at point B. So now if we look at the red triangle, BC will be the hypotenuse. And M is actually the opposite side. And 6.3 will become the adjacent. Now, because I'm finding M, I am going to use the opposite. And I'm given 6.3, so I'm going to use the adjacent. So there's no need to use hypotenuse because we don't know it, and that's not the question. So the ratio we want to use is a ratio that has an O and an A. And very quickly, that's 2R. So we can write down 10 of the angle 18.7 is actually equal to opposite over adjacent. Looking at the diagram, opposite is M, and your adjacent is 6.3. I'm going to put that over 1. And now we're going to do a cross multiplication. M times 1 is M. And 10, 18.7 times 6.3 would be 6.3 times 10, 18.7. And can someone type that in for me? So I'm getting 2.1. Waiting for a confirmation.
Yes, sir.
Now, guys, also, I don't want spectators here. I hope you're working with me. So let me give you some time. Take a pen, take a page out. Don't just, this is not to entertain you. This is not a movie night. So you're going to be working with me. So I'm going to stop now and say now, right, I showed you how to find M. I'm going to give you about 2 or 3 minutes to find the next one, which is N. Your job now is to go and find N. Okay, I'm going to move on. So in the second question, they want us to find N. So I'm going to highlight the triangle next door in purple. So remember, if that's 90 angles on a straight line, we know the other angle there is 90. So in the last question, we found M. So we can put the measurement down there, that M is 2.1. So now you'll notice that I don't have an angle. Now forget about the 90 degrees. We're going to use that for the hypotenuse. So if we look at the big triangle, we can use some angles of a triangle to find angle A. Can someone quickly work that out and give me an answer? Did everyone get 71.3?
Yes, sir.
All right, we can use some angles of a triangle. In other words, 180 minus the 90 here, minus the 18.7 will give us the 7.13 we're looking for. So I'm putting it into my diagram. Now, looking at the purple triangle, M, which is 2.1, is opposite 71.3. So it will stay as the opposite. We're going to use 2.1 because it's given. Then I'm going to use N because that's a question to find N. And N compared to 7.13 is actually the adjacent side. Am I right? Somebody said no. Why am I wrong?
So it's the hypotenuse, sir, because it's
you.
opposite 90.
It's opposite the right angle. That should be the hypotenuse. So I'm going to use O and H. Now, if we look at SOHCAHTOA, let's quickly write that down. SOHCAHTOA. We want a ratio that has an O and an H, and that is sine. So we can now say sine, the angle is 71.3, is equal to opposite over hypotenuse. The opposite side is 2.1, and the hypotenuse is what we want to find N. So we're going to now use a cross multiplication technique, and we will get N sine 71.3 is equal to 2.1 times 1 is 2.1. To find N, we're going to divide by sine 71.3. And someone take out a calculator and quickly help me out there.
2.2, sir.
2.2. Can we have a confirmation on that?
Yes, sir.
We seem to have agreement there. Okay, let me check what my answer is. So if I look at my answer there, which I'm going to delete all my writing to get back to the PowerPoint, I'm getting n to be 2.3. For those of you who need to see that. Okay, so this is a simple application into right angle triangles using SOHCAHTOA. Okay, I think we're going to skip this one. If we have time, we'll come back. So let's look at this question. This is a nice question. I think some of you have done this one before. So let's just go through this question. I like this question. Nice word problems, heavily loaded with words. So it's nice to interpret. So it says in the sketch below, a drone D is flying directly above a tracking vehicle T. So there we have a drone flying above a tracking vehicle. It is in contact with a command center C, watching a poaching gang P. There's a gang here, about to attack a rhino R. Very nice story this is. And it says calculate the distance that a signal from the drone to the command center has to travel, that is DC. So they want us to find DC. Now, if we forget about all the words which are heavily loaded, just look at the diagram, you see triangles. And the first question there, let's highlight it. It wants us to find DC. Now, we need a right angle triangle. To use sine, cos, and theta, we need a right angle. So we know that DT, because they told us it's directly above. If it's directly above, indirectly, that they are trying to tell us that angle is 90 degrees. So we have our first triangle. Now we have the angle given to be 10. So in the red triangle, we need to find out. They want us to find DC. So in reference to 10, what will DC be? Will it be hypotenuse, opposite, or adjacent in the red triangle?
Hypotenuse, sir.
It's opposite the right angle triangle. I mean, right angle. Well done. It has to be the hypotenuse. Now we have a choice. We can either use CT or we could use DT. Now immediately you can see DT is given. So we're going to use DT, and DT from 10 is actually opposite. So now we need a trig ratio that has a O. I can stop. So can you see immediately? So has an O and an H. So we can immediately say sine of the angle 10 is equal to opposite over hypotenuse. The opposite is 150, and the hypotenuse is what we want to find. We don't know it. We're going to call it DC. Give you some time, quickly work that out. Okay.
Oh, excuse me, sir.
Yes.
So could you use tan in that situation, sir?
Right. Let's see if can we use 10. Good question. If I use 10, then the ratio is opposite over adjacent. Now the problem is I don't know CT. Can you see that? If you use 10, you're going to use opposite over adjacent, and you don't know CT, so you can't use 10.
Oh, yes, sir. Yes, sir.
So after cross multiplying, we're going to divide both sides by sine 10. Can someone help me with an answer there? 150 divided by sine 10.
863.8, sir.
863.8. Now, depends on the question paper, how many decimals they tell you to round off. So always remember to read your instructions. Is it 2 or 1? So I can't tell you what the paper is going to be. So be prepared for that in terms of rounding off. So when you find it is important on lead-on questions to put into the diagram. Right, we're ready to move on. So let's read the next question. Calculate the angle that the camera on the drone has to move from the vertical to the poaching gang's position, that is angle TDP. I want you firstly to highlight the triangle. Sorry, I went a little too fast there. Yeah, I'm just erasing my diagram here so that give you some time to work that out as well. Okay, so I'm on the second question now. Okay, my page is now cleared. So I'm going to highlight, because the question is saying TDP. So I want to find this angle. So that is the triangle that is present in, the purple triangle. Can everyone see that purple triangle there? And we know that angle is 90. So let's give that angle a name. Let's call it theta. Okay. So now if we want to find the angle, we need to look at the triangle. You have to have, you see, if you're finding theta, if I'm finding theta, I need to have two given sides because you can't have two unknowns. So theta is unknown. So I have to use two sides that are given. So if we look at the diagram from theta, what would 150 be? That would be our adjacent. And if we look from theta, the 560 is opposite the 90 degrees. So that is our hypotenuse. So which ratio will I use? So, ka, or tua? Someone to help me out there? Which ratio will I use?
Cos, sir.
Cos. Well done. Second one says cos is equal to adjacent over hypotenuse. So, in using that, we're going to say cos theta is equal to, and everyone said adjacent over hypotenuse. If we look at the diagram, the adjacent is 150 over hypotenuse 5. So now we are finding an angle. If ever you are finding an angle, so there is only one way that you can get rid of cos. And the only way you can get rid of cos is to use on your calculator shift. So you will have to type shift cos 150 over 560. Calculators out. I can open my calculator and share it on the screen, but I think your teacher must have showed you how to use shift. Shift cos 150 over 560. Can I have an answer?
76.58.
76.58. Can we have someone confirm that?
74, sir.
Oh, now I have a problem. I got two
I
answers.
also got 74, sir. What 74, sir?
74, sir.
Okay. Democracy here. Democracy is not always right, but I'm going to go with that. 74 point.
46.
Okay, 74.46. If it's wrong,
Oh, no, it's not recurring, sir.
so we got 74.46. Now remember, the question was not to find theta. The question is to find TDP. So you have to end off by saying, all right, because I didn't use the angle directly, TDP is actually 74.46. If you use it directly and then use theta, then you don't have a problem there. Okay, we're going to the next question. So while I'm erasing my diagram, you can carry on trying that question.
Sorry, sir.
Yes,
You said something about if you don't use cos, it was glitching. I didn't hear what you said.
I'm not sure what you're referring to.
So if you're not calculating theta directly or something.
You need to be, if you're calculating theta, you have to have two given sides. You can't have two unknowns.
Oh, yes, sir.
Okay.
Thank you, sir.
All right, the next question is to find PR. Now remember the previous question, we found the angle here to be 74.46. Can we put that down? Okay, so just remember that 74.46. Now, if we're trying to find PR, we need a right angle triangle, guys. Do you see a problem? If you highlight DPR, it's not a right angle triangle. Yes or no?
Yes, sir.
Yes, yes.
Very good. That's the first point you have realized. So what are we going to do here?
So can you use the big triangle, sir?
Very good.
RT.
You can use the big triangle and find
And
RT.
find the total length and then minus it by the TDP, sir. The length
Very
of TP, sir.
So what you need to see that PR is actually equal to the big side TR minus TP. Now, the reason why we're using that is, can we find TP? Yes, we can find TP. Would you agree with that? If we go back to our triangle, the purple triangle, because we got an angle called 74.6, we can find TP. Quickly find TP using triangle DTP, and then you can find TR using the big triangle. So let me give you some time to work that out before I actually come in. Okay, I'm going to come in now. If we look at triangle DTP, which I've highlighted, so we're looking from an angle called 74.6 because we found it. So we want to find TP. So TP compared to 74.6 is our opposite side. And now we have a choice. We have both the other sides given, so you can use any one you want. So I'm going to use the adjacent. So if I'm using the adjacent, I'm using SOHCAHTOA, so I'm going to use tan. So I can make a statement that tan 74.46 is equal to opposite. Tan is opposite of adjacent. And if we're looking at the opposite side, that's what we're going to find. So we can find that. That's TP over the adjacent side of 150. Put that over 1. We're going to cross multiply. TP times 1 is TP. And then we can multiply tan 74.46 times 150. Can I have an answer there?
539.42.
So I'm getting an answer of, okay, let me just make a note of that answer. I just want to get my eraser out to take this out. All right. Can I have that answer again?
539,42.
Can we have someone to confirm that answer?
Yes, sir.
Yes, sir. Okay, so we found TP. So remember, what is our goal here? Our goal is to find PR, but we cannot go direct to PR because PR is not in a right angle triangle. So our next point now that we want to do is going to the big triangle. So I'm going to highlight the big triangle, which I want to change my color on. So if we go to the big triangle, and I'm highlighting that in green. And you can see that's the right angle triangle we want to refer to. So if we look at the green triangle, that's the big triangle, all right? The angle given is 12. So we can look from this degrees called 12. So in looking from 12, I'm going to use, now I'm going to take out all my markings there. Let me do that first because I'm onto a new triangle now. So okay, let's take out adjacent there. And then we're going to bring back. So from 12 degrees, we're going to use 150 because it's given. So that should be the opposite side. And we want to find TR, the whole side. That TR is actually the adjacent in the green triangle. So the ratio that we want to use, which ratio will I use?
Tan, sir.
Why would you use tan? Why not cos or sine?
Because we've got the opposite and adjacent, sir.
Thank you. And from SOHCAHTOA, we know that, sorry, I'm just trying to get my pen out here. Okay, so somebody said TOA, totally correct. You can see TOA, tan, so we're going to say tan, and we're looking from 12 degrees. Will be equal to opposite, which is 150, over the adjacent side, which we don't know is TR. And we're going to cross multiply, which will give us TR times tan 12 is equal to 150. And then we're going to divide both sides. We're going to divide both sides to find TR. We need to get rid of tan 12, so we divide by that. It's an equation. You've got to do the same thing on the other side. Tan 12. And can someone type that in and give me the answer there?
So it's 705,69, sir.
Can someone confirm that?
Yes, sir.
Okay, so the last part we're going to end. How do we find PR? So PR will be the big side. TR, remember we started with that, which is 705.69. And we're going to subtract TP, which is 539.42. And you can type that on a calculator, and that is the answer we're actually looking for there. Any questions on that?
Sorry, sir.
Yes.
So for triangle TDP, DTP, sir, can't you also use sine to solve TP, sir?
Yeah, you can. If you're looking from 74.46. Wait,
Yes,
I'm
sir.
not with you. So if we're looking from
So
70, sine will be opposite over hypotenuse.
hypotenuse, yes, sir.
You can, because you have the 560. So both will work.
Oh, yes.
All right. Ready to move on? So those are what we look at right angle triangles and using sine, cosine, tan. Okay, and then we're going to have questions where you have to find using your calculator, like what I have here, theta. All right, so what you got to remember is that the angle theta is married to sine. Okay, remember that because it causes a lot of confusions later, and I'll point that out. So in this case, it's quite simple. How do we get rid of sine? The only way that you can get rid of sine, I told you that a little earlier, is you have to use shift on your calculator. So you will say shift sine 0.451. And what would we get? You get it 26.8.
Yes, sir.
Yes, sir.
26.8 degrees. Are we all happy with that?
Yes, sir.
Doesn't look like everyone is happy with that angle. So we got 26.8. Now I want to show you two important things that most grade 10 students confuse. All right, and I know that some of you are here today and we don't want you to make the same mistake in the paper. So you get two scenarios. You can get a 2 sine theta is equal to, say, a number called 5. Or you could get sine 2 theta is equal to, let's say, 1/5. So I want you to take your calculators out and quickly work out theta. Let me give you a minute. Calculators out. It says 1 decimal place, so it means use your calculator. Okay, so the reason why I put these two questions down, there's a big difference here. So let's look at the first case. So we have a 2 in front of sine. Now to get rid of the 2, it's like saying 2 times sine theta, and the inverse operation of multiplication in maths is called division. So in this case, I can divide by 2. All right, and you'll see your 2's will cancel off. And then you can type in, well, if I simplify that, it's sine theta is equal to, actually this question won't work out. You'll get a maths error, am I right? Yes or no?
Yes, sir.
Yes,
You'll
yes,
get a maths. So to make this question work, let's make it equal to 1. Change that 5 to 1. All right, we're going to divide both sides by 2. So now if we type shift sine half, what would we get? Are we getting 30 degrees?
yes, sir.
All right. Now, there are two answers to this because we know sine is also positive in quadrant 2, but I don't think we're going to that level in grade 10. So I'm going to say that because I'm being recorded, all right, that we would get a second angle for this in a range of 0 to 360, but we're not going to go there. But look at the second case. Can you divide by 2 in the second case?
No,
No,
sir.
sir.
No, right.
No, sir. You have to.
This whole thing is the angle. It's married to sine. The only way you get rid of sine is by using your calculator called, using a shift button. So now you're going to type shift sine. Shift sine 1/5. What do we get now?
11,53, sir.
11,53. Now that you got rid of the sine, now you can go and divide both sides by 2 to find theta. So we get 11.53 divided by 2. Give me an angle.
It's 5,76, sir.
5,76. All right. Can you see the difference here? So in this case, you cannot go and divide by 2 initially. You can only divide by 2 once you got rid of sine because the entire angle was 2 theta. So that is a common confusion in grade 10. And the reason why it's such a common mistake is because this is the first time you're doing trig. So you will get used to it as you're moving on. Okay, so I'm happy with that. Let's move on. All right. Look at this question. It's coming from a past paper. And I'm not sure which past paper it's coming from. So I'm going to give you some time to try this question out before I actually work. Okay, I assume you had some time to look at it. It says if theta is between 0 to 90, all that means to you is, you know what? We're actually in quadrant 1. Okay, so that's what they're trying to tell us there. So we can ignore that for now. Solve for theta in each of the following questions. And the question is, you've got 2 sine theta plus 1 is equal to 1.28. So what we're going to do in this case is the first thing we're going to do is take the plus 1 on the other side. So we're going to have 2 sine theta. And if the plus 1 goes, that's it, it becomes a minus 1. So 1.28 minus 1 is 0.28. Then we notice the 2 is in front of the sign, so we can divide both sides by 2. And you'll notice your 2 will cancel off. And then you have sine theta. And remember what we said, to get rid of the sign, you use shift. So if you use your calculator now and say shift sine 0.28 divided by 2, what do we get?
8,05, sir.
Can we have confirmation?
Yes, sir.
Yes, sir.
And remember, we're finding an angle, so we want to put a degrees there. Okay. So the next question is a little more tricky. It says tan 2 theta is equal to 4. Now, I don't think we're getting a inverse ratios in this paper. This one has a cot, so I'm going to change it for you. Cot is basically 1 over 10, if you didn't know that. But in your paper, I don't think we're doing, what did your teachers tell you? Are you getting inverse ratios? Okay, so what I'm going to do is change that question and make it tan 2 theta is equal to 4 over tan 60. Now, I want you to go and find theta, so I'm going to help you. So we know tan 2 theta would be equal to, now we can take our calculator out. What is 4 over tan 60? Can someone type that in for me?
Two comma 3 1, sir.
Can we have someone to confirm that?
Yes, sir. I got that too, sir.
Did you get an
Yes, sir.
exact answer of 2.31 or did you round off?
Round off, sir.
Round.
Right, very dangerous what we did, right? So we don't want to round off so early. Okay, let me just get back to my. So remember, you only round off at the end. So can I have more decimals there? 2.31, can we have the actual 4 decimals?
2.3094, sir.
Right, so remember that now for the 2.3094, you said. Now I am right by saying that you still have that on your calculator. So now what you can do is type, to get rid of 10, we say shift 10. Shift 10, and if you press your answer button, because it's still on your calculator, or you could type in 2.309. And then you should be getting an answer. Can someone help me with shift 10? And what do we get here? Somebody? Anybody?
So I think-
66,58, sir.
Yes,
Five
yes, sir.
nine.
That's right, sir.
Don't round off 66, comma.
5867.
All right. And then now we're ready to round off. Divide both sides by 2. You can now round off to, let's say, 2 decimal places. What do we get now?
33,29, sir.
33,29 degrees. So just watch a round off error. You only round off at the end. All right, so I'm now going to look at the next type of question where we're going to use a diagram. So let's look at this question here. They tell us that tan theta is equal to 4/3, and theta is between 0 to 90. It says illustrate this in a sketch. In other words, draw a diagram, or in other words, draw a triangle. So if we're using a diagram, we're looking for a right angle triangle, all right? This is telling us that we are in quadrant 1. So if we quickly draw a diagram, in quadrant 1, we want to draw a right angle triangle. And the reference angle there is theta. Now we got to go, remember we're now on a Cartesian plane. So we're not going to use SOHCAHTOA, we're going to use X, Y, and R. So if we look at tan by definition is Y over X. Okay, before I get into my PowerPoint. So tan by definition is Y over X. So if you go to your diagram, your X value is 3 and your Y value is 4. So using Pythagoras, we can find the radius. Any questions? Okay, I'm going to rub that out. And now go through this with a slide projection because I explained the basics. Okay, so going back to the point, if they're giving you tan theta is equal to 4/3, that actually means Y over X in your Cartesian plane. So if we now put the diagram together, the Y value is 4 and the X value is 3. And we can now take that and conclude that on the x-axis, that's 3, on the y-axis, that's 4. And using Pythagoras, we can find r squared. And we know r squared will be 4 squared plus 3 squared, giving you 25. And to find r, you got to find the square root of 25, which is 5. So an important point for you to note, you see number 2 said use Pythagoras. Whenever they give you sine, cos, and tan, if they give you sine, cos, or tan, they're giving you 2 sides. So using Pythagoras, you'll have to find the third side. And once we got the third side, we can find all the trig ratios. Because if we summarize this, before we go find that, so we now have a conclusion here that x is 3, y is 4, could have put it there, 3, 4, and we found r to be 5. So if you think about all your ratios, sine theta, what is sine theta? Sine theta is y over r. We can go to our diagram. The y value is 4, because sine is y over r. If we go to cos, cos is x over r. Remember in the beginning I said learn your definitions. That's your definition of cos. The x value is 3 over 5. And then we got tan theta. And if we look at tan theta, it's y over x, which they gave us. Confirmation, it's 4/3. So in a diagram question, 2 sides will be given. You will use Pythagoras to find the third side. Any questions before I go on? Okay, so there we have a question that came out in the past paper. Let's give you some time to try this one out. It says in the diagram, P is a point -5, 12. And now they want us to find cos theta. And so let's give you some time. Okay, in a diagram question like this, we know that's x. That skipped me very quickly. So in a question like this, we know that this is x and that is y. So we got to finish, we drop a perpendicular to the x-axis, always to the x-axis. So we have a right angle triangle. The x value we're saying is -5. The y value is 12. So to find OP, that's what we're trying to find, which is the radius. we will say r squared is equal to 12 squared plus, wherever you find a radius, you'll say plus. If you're finding x and y, you'll say the radius minus the other side. So we got a minus 5 squared. And you can type that directly on your calculator. There's no need to show each step. 12 squared, but you got to have a reason, and a reason that we should be stating here is Pythagoras. Okay, remember to write your reason. Could lose a mark. 144 plus 25 is 169. So r becomes the root of 169, which is actually 13. So we know our x value, we know our y value, and we know our r value. So what is cos by definition? Cos is actually x over r. And if we look at our diagram, our x value is minus 5 over 13. So you're going to get a question as well. What is sine theta? Let's do more questions, right? Just to get the feel of this. Another question they could, sorry. All right, another question they could ask here, number 2. I'm making up my own questions here. Sorry, can you guys see what's on my screen now?
Yes, sir.
Yes, sir.
Okay, so if we look at the next question, that so if we look at this question, let's make our own question. I said, all right. So let's suppose we got a question called sine theta over cos theta. Just want to get my pen back in operation. All right. So we want to find out what is sine theta over cos theta using our diagram. So we go to the diagram. Sine is y over r. Let's write it down. And cos is actually x over r. So put that as a fraction. Sine, we said, is y over r. The y value is 12. The r value is 13. And then we want your cos value. Cos is x over r. The x value is minus 5 over 13. Now, we know in primary school, they taught us fraction divided by fraction, you invert and multiply. 12 over 13 multiplied, and you flip the bottom. Yes.
So I can't see your screen, sir.
Yes, sir. It's frozen, sir.
Oh, it's frozen. Okay, let me share that again. Can you see it now?
Yes, sir.
Okay, so the question I had was sine theta over cos theta, and I said sine is y over r, cos is x over r. And then we're taking it directly from the diagram. And a fraction divided by a fraction is 12 over 13, and then you multiply by the inverse, which will be 13 over minus 5. And your 13s will cancel off, and you're left with 12 over minus 5. Any questions on that? Okay, I'm going to give you one more before I move on. I want you to use your diagram because I know this question here, I've got some smart guys in this lesson here, and they could give me the answer direct, but I'm going to make this a 4-mark question. That means you're going to show all the working. I want you using the diagram and not using what you learned in class now, but using the diagram directly. How would we work out sine squared theta plus cos squared theta? Okay, I know if you're sitting, maybe you've done this in your class, that sine squared plus cos squared is actually 1. It's a formula, but now we want to show it from the diagram. So if we go to the diagram, sine is y over r. So you're going to get 12 over 13 all squared. Plus your cos value there is x over r, which is negative. Okay, so that's negative 5 over 13 all squared. So we now, 12 squared is 144 over 169. Remember they said use a diagram, so no calculators allowed here. Plus minus 5 squared would give me 25 over 169. We got a common denominator of 169. So we're going to take 144 plus 25. And then we get 169 divided by 169 should give me a total answer of 1. Proving that sine squared cos squared is actually 1. Okay, but that's how we show it would working for 4 marks. Any questions?
So on the was for the first question, sir. Are we not actually working out the angle theta, sir?
There's no question saying you to find the angle theta. Where did it say that?
Or it says determine the value of cos theta, sir.
Yeah, they didn't tell you find theta. They told you find cos theta. Remember, cos is a ratio. You're not finding an angle. You
Okay.
find a fraction.
Thank you, sir.
So this is what a question would look like if they told you to do that. Good question. So if they wanted you to find the angle, then your question will read as follows. And now, so the question will say like a 4.32, which will say find theta to 1 decimal place. When they say 1 decimal place, it means you have to use the calculator. So to do that, you know cos theta is equal to minus 5 over 13. So you're going to use your shift cos, but don't use minus. You use shift cos 5 over 13. What angle do we get?
It's like 114, sir.
114 degrees. But remember, oh, I can't be getting 114 directly. If you use shift cos 5 over 13, what would you get?
67. sir.
67. All right. That's your angle inside the triangle. So theta would actually be equal to, it's a straight line, or in a second quadrant. That's a 180 minus 67. And what would you get now? 113. Because we're now in the second quadrant and not in the first quadrant. If we were in the first quadrant, we will stay with that angle. It's an accurate angle. We're no more in the first quadrant. Is that answer right? Shift cos 5 over 13. Can I have confirmation on that? Is that 67?
Yes, sir.
Okay, so those are your diagram questions, which I think I've covered now. You can practice more on your own. So I think that's fine for trig. I decided to do trig first because it's a new section, okay? And I'm going to skip that one. You can find that in the past paper. Don't worry about that sound. So we come to the next section that you do is called special angles. So the angles that are special to you is 0, 30, 45, 60, 90. But okay, we're not going to go too deep. The ones you do in grade 10. For 0, 90, 180, 273, 60, you can use your calculator. In other words, any multiple of 90, you can use your calculator. So you can use your calculator, but you got to show working. If you don't show working, now I know in class, I showed the guys how to work this out without a calculator. Now we don't have time for that because remember, I've only got limited time. So you can go back to the notes, but look at this question. Okay, let's do one together with. So let me go back there, right? So if you get a question like 4 sine 30, cos 45, what working are they talking about? So you'll take your calculator, your 4 will come down as a fraction 4 over 1. Sine 30, you'll type on the calculator. What would you get if you type sine 30? Are you getting half?
Yes, sir.
And if you type cos 45? Are you getting root 2 over 2?
Yes, sir.
So this is how they will mark your paper. You use your calculator, you put half, you get a mark. Sine cos 45, when you say root 2 over 2, you get a mark. Then you got to show your working. So if we actually work this out, 4 times 1 times root 2 is actually 4 root 2. And 1 times 2 times 2 is 4. And then the 4s will cancel off. You'll have to root 2. So can you see it? You must show your working. Anybody who goes straight to the answer, that means you type this directly on your calculator, you come to root 2, will give you 0. So there's your mark scheme. 1 mark, 1 mark, 1 mark. So that'll be a 3-mark question. Right. If we go to the next one, sine squared 270. So you're allowed to type your sine 270, not the squared. You'll type sine 270 on the calculator. Try it out. Do you get -1?
Yes, sir.
So you put -1 with a square now. If you put 1, you lose the mark. Then you go to cos 30. Don't type square. You'll type only, you're not allowed to type cos 30. Should give you root 3 over 2. Is it giving you root 3 over 2? Yes or no?
Yes, sir.
All right. Then you'll get a mark for that and you put your square. And then you'll type 1045, and we all know 1045. Please memorize this one. It's very important for graphs. 1045 is 1. So there's your 3 marks. And then -1 squared is 1. Root 3 squared is 3. 2 squared is 4. Plus 1. So there's your second mark there. Actually, 4th mark. And then we can add 1 plus 1 is 2. 2 3/4. So this could be like a 4 or 5 mark question. Okay, so that's how we deal with special angles. Don't worry about that exercise. Okay, so something for you to try out on your calculator. If you type sine 30 over cos 30, what do you get?
Root 3 over 3, sir.
Now they said without the calculator, can you see? So what do they want to see from us? So they want to see the steps. Sine 30 is half, cos 30 is root 3 over 2. So remember what I said, a fraction divided by a fraction, you invert and multiply. So you see your 2's will cancel off, you're left with 1 over root 3. Somebody said if you type directly, what would you have got? Root 3 over?
Over 3, sir.
Over 3,
That's the
sir.
same thing as 1 over root 3. Okay, the calculator has rationalized the denominator. But let's now type on our calculator. If you type sine 30, are you getting half? Hey, a little faster would help me tonight.
Yes, sir. It's half, sir.
Yeah.
Now type cos 30, what do you get?
Root 3 over 2, sir.
Okay, can you see now how this thing is working out, all right? And then from there, we can go and type. I mean, we can do the working out, which gives us the 1 over root 3. Okay, so I'm not interested in what is the calculator saying? Root 3 over 3. Now, how can we actually make a resemblance and say this? Watch. 1 over root 3. If we multiply, you see, to make a denominator rational means we don't want a square root, right? So we'll times this by, we multiply this by root 3 and we multiply the top by root 3. So we've actually multiplied root 3 over root 3 is 1. And if you work this out, that'll give you root 3 times root 3 is 3. But this is just, by the way, not to worry about this for the exam. So I'm going to ignore this. Don't worry about this for the exam, okay? That's just some added information. That a calculator will simplify or rationalize the denominator. So we will go with either the rational or the irrational. So don't worry about that. If you're confused, this is not important for you now. So I'm going to skip this. Okay, let's look at this question. This is now coming to what the paper wants. So if we look at 3.1, the question is, they give you X and they give you Y. And they say find sine squared x plus 2 cos y. So all you have to do is say, right, sine, you're substituting. And they did not tell you that you're not allowed to use a calculator now. Can we all see that they didn't say don't use the calculator? So when they don't say, if they didn't tell you don't use the calculator, then you're allowed to use it. So you're going to say sine squared. The question was x, and x, you know, is 37 plus 2 cos y, and y is 44. And all you're going to do now is type that in. As you see it, what answer do you get?
2.0404, sir.
Right, you can round off to 2 decimal places.
2.04, sir.
Okay, so I'm quite happy with that one. Let's go to the next question. Okay, if we look at the next question, well, this was giving you some time to read that. So we're going to do this together. Take your calculators out. It says sine 30. What is sine 30 on your calculator? Is it a half?
Yes, sir.
All right, now cot 45. Now that is the inverse of 10. So if you want to know what is cot 45, you type in tan 45. What is tan 45?
1, sir.
And then you flip it. If you flip 1, it's still 1. Are we all happy with that? And then you got cos 30. Type in cos 30.
√3/2, sir.
Okay. And then we're going to type in tan 60. What do we get for tan 60?
√3, sir.
√3 as a
1.
fraction, it'll be √3/1. So we all know on the top, half times 1 is half. Anything times 1 is the same thing. And then the bottom, are √3 times √3 is 3. And 2 times 1 is 2. So we have a fraction over a fraction. And the rule is invert and multiply. So that becomes 2/3. And you see your 2's will cancel off, and we're left with 1/3.
Sorry,
Okay.
sir.
Yes.
So how did you get the 1 at the top, sir?
Well, you got to know that the inverse of cot is tan. So you'll type in tan 45. And then you flip it.
So I thought you weren't allowed to use a calculator, sir.
I think, young man, we've been using a calculator for sine 30, cos 30, as long as you show you're working. Okay?
Okay, sir.
We can do this without a calculator. Trust me. Okay, we just don't have the time to go into the tables now. And if you're sitting in my class will bear me up. Is Mr. Maestri's class here today? Can someone just remind us, what do we use to find this without a calculator?
You can use the triangles, sir.
We can use the triangles, but we don't have the time now to go into the triangles, okay? And you can use your calculator as long as you show you're working. Yeah, we're gonna skip quadrants. I don't need that for now because of time. We don't need to know about the quadrants for now. So I'm gonna skip all that. Okay. All right, I've come to the end of the session with the I want to go into some trig graphs quickly now. I'm just doing a walkthrough. Okay, so I'm going to share the screen now with you. Share. Okay, can everyone see the screen now?
Yes, sir.
Right, what is it? This question now is about trig graphs. So let's look at the first question. It says, consider the functions 2 cos x and g of x is equal to minus sine x plus 1. I want you to write these two functions down because I'm going to share now a calculator with you. So quickly write this down. And we're going to use a calculator that's going to assist us in drawing those two graphs. So I'm going to open my calculator. The good thing is I do have a calculator on my computer. I just got to get it to share with you. Okay, my calculator is not popping up now. It wants me to activate the license. Okay, so I'm going to help you out. There's two ways we can use a calculator. How many of you know how to, do you remember how to use the table function?
Yes, sir.
Right. There's a young man who said yes. Who was that young man?
Kufel, sir.
Sorry, who?
Kufel, sir.
Right. You tell us what you're going to do on your calculator. Type in y is equal to 2 cos x. Lead us. You now have the mic. The mic is on you. Go for it.
So first you have to change your calculator to table mode, which you click mode and then click 3 for table. And then it'll say f of x equals. And then you type in 2 cos x.
Okay, so
Well,
let's stop
alpha.
there. Right. So everyone's got that. Bring your calculator in table mode. You're going to type in y equal to 2 cos x. To get the x, you might have to type alpha. Right. Carry on, young man.
And then you press equals, and then you type in your g of x.
We've got two functions, and you can type in your g of x, which is minus sine x plus 1. If you don't have two functions, then you just press enter for g of x. All right, carry on.
Then you click equals, and then it'll say start, which you have as 0.
Right, your start will be your axis that's given in the exam. So I'm starting this one at 0, and we're going to say the end point will be 360. So your start is 0, your end is 360. What comes up next?
Steps, so which
your
will be 45 for
Yes,
this
you
graph.
we'll have to use what they give you. I'm stepping this diagram up in 45s. And then you press equal to, and you'll see all your values. Come on. Now, if you don't know how to do that, then you can just do it a little bit more work. And when you're on 0, what you want to type in? 2 cos 0. What is 2 cos 0 on your calculator? What is 2 cos 0? Are we getting 2?
2, sir.
Yes, sir.
Let's move a little fast. If you have the table, that's fine. If you don't have the table, then the next point, when it's 45, you'll type 2 cos 45. Can I have an answer?
Sorry, please repeat that, sir.
I'm trying to draw I'm on 45. Now you're going to type 2 cos 45. If you have the table, just go with the table. So what point are we getting at 45?
1.41, sir.
So 1.4, and we're going to estimate, all right? 1.41 will just be just below. Right, then we're going to go to 90. When we are 90, we're typing 2 cos 90, or we're getting it directly from the table. What do we get?
0, sir.
0. And then we're going to go to 135. We're going to type in 2 cos 135. What do we get in our calculator?
Negative 1.41, sir.
So we're going to estimate around there. Then we go to 180. And I think 180 is minus 2.
Yes, sir.
Then we come to 225, which will be minus 1.4. Then we come to 270. And what is 270? We're back at 0. Then we come to 315, which will take us back to 1.4. Am I right?
Yes, sir.
And then we go to 360, we're back to 2. So we join all these points. and we get the cost graph. And that's how you draw a cost graph for 3 marks. All right, in the same way, we can draw the sine graph. So I just want to change my color of pen there. All right, let's go draw the sine graph. So at 0, if we type in minus sine 0 plus 1, what do we get? Would we get 1? Hey, that's wrong. Is it
Yes,
right
sir.
or wrong?
So I got 1, sir.
Very well done. Let's move on. So when we go to 45, we type minus sine 45, or read for me from the table. You guys who got a table, just help me out there. Let's move a little faster. At 45, what is your y value?
Negative 0.71, sir.
Negative 0.71. I'm going to estimate. All right, thank you. Let's move. At 90.
0.99, sir.
I don't like that answer. Can we type that in? What if we type minus sine 90 plus 1? What do we get?
0, sir.
0. Guys, we're getting 2 different answers now. I'm worried. And I don't have my calculator on me. I should have brought it. Okay, can I have some seconders on people typing, because the people are not typing correctly here? Let's go again. At 45, if you type minus sine 45 plus 1, what are you getting?
0.
0.70.
Right, so I've got a 0.70 mark. Now type in your 90, minus sine 90 plus 1.
Oh, sorry, sir. That one was negative 0.99.
Mr. Pillay, you with us, Mr. Pillay? Can you confirm that? Okay, guys, I'm going to fetch my calculator. You carry on drawing this graph while I fetch my calculator, because I'm doubting. Gentlemen, I've got my calculator now. Are we all ready? I now have my own calculator. I was really worried, guys, give me wrong answers here. So let's see now if we agree. At 0, according to my table, I'm getting 1. Are we all in agreement? Yes or no? Hello, is everyone with me still?
Yes, sir.
Yes, sir.
At 45, I'm getting 0.29. Are you getting 0.29?
Yes, sir.
They're about 0.3. So I don't know where these guys are getting minus 1 point something. And at 90, I'm getting 0. Yes or no? Are we in agreement now?
Yes, sir.
Yes.
At 135, we're getting 0.3 again. I'm going to round off. It's 0.29. I'm rounding off to 3. At 180, I'm getting 1. See, if you want to do something in life, you do it yourself, you do it properly. And then at 225, I'm getting 1.7. Are you guys getting that?
Yes, sir.
Yes or no? And then at 270, I'm getting 2. Are you guys getting that?
No, sir. I'm not. I'm getting 0 comma digits, sir.
Okay. All right. Let's quickly look at that. So let's look at a normal sine graph. What will a normal sine graph look like for you guys who are struggling there? A normal sine graph looks like this, all right? It starts at 0 at 180, and there's your 360, and there's your 90, and there's your 270. So a minus graph would mean we're going in a reverse direction. Okay, and then we're shifting the graph 1 unit up. So the 0 should actually start at 1. Okay, and this point. So I think you're typing wrong, young man. Let's go back now. It's a typing problem. What have you typed in? So then at 315, I'm getting 1.7. And then at 360, we're getting 1. So that looks perfect to me. So you guys who are not getting this, go back to your function. Your function that you're typing is incorrect. And that's where our sine graph is going to look like. Okay. I can't help you there because it's a calculator reading. And look at the function. There's your function right here. It says minus sine x plus 1. So go to your table and check if you typed in minus sine x plus 1. You have to return. So it is a typo error on your calculator. Who's getting the points I got and whose graph is looking like my one? Can I have one confirmation to make me happy today?
Yes, sir. Yes, sir.
Right, sir. Yes, sir.
That's
you.
good, sir.
All right. Okay, let's move on. Let's talk a little bit of this graph. What is the 2 in front telling me? Let's look at F. What is the 2 in front telling me? It's telling me that my amplitude for this graph is 2. Are we all in agreement there?
Yes, sir.
Okay. So the question here is find the range of f of x. If we look at the red graph, your lowest value is -2 and your highest value is 2. So our range would be y is the element. Y is the element running from -2 to 2. While we're at it, what would be the range of G? I know that's not the question, but what would our range of G be?
Would it be -1, sir?
No, the blue graph, the lowest value on the blue graph is 0. Can you see that? And the highest value
0 to 2,
goes to
sir.
2. Yes, it goes to 2, right? So for the G graph, we should have said, I'm going to write that down. For the G graph, the range would be 0 to 2. Now, they say state the amplitude of G. Most people in grade 10 are going to tell us if this was the exam, they're going to look at the graph, they're going to say it's 2. And they would be wrong. Who can tell me what the amplitude for the G graph is?
It's 1, sir.
Thank you. It's 1. Because an amplitude by definition is the highest displacement from a point of rest. So there's your halfway. Can you see that? So my maximum displacement there would be 1 unit. Or the easy way to look at it is take your highest minus your lowest. 2 minus 0 is 2. That's your total distance, and divide by 2, which would give you 1. What is the period of the cos graph? The period on this cos graph from year to year to complete its whole cycle is 360. The period of the sine graph is also 360. So that's a 6, 8, 9 mark question. Good question. Okay. If we look at the next question that I don't have written down, I'd like to just do it very quickly. If we had to draw a graph for 10 is good practice, you know. Y is equal to 10x. So, calculator's out. I've got my calculator here with me. You go now, your f of x, put your calculator, mode. In my calculator, it says 7 for table, and then I'm going to type my function in. 10 alpha x. Close my bracket, equal to my starting point on this graph is 0. No, sorry, g of x will come up. You can press enter or 0 on that one. Your starting value here is 0. Your ending value is 360. And your step according to this graph is 45. So if I look at my calculator now, at 0, it is 0. We're accepting that. At 45, my calculator says 1. I hope your calculator is saying that. At 90, we're getting a math error. So that means that's an asymptote. On 135, I'm getting -1. On 180, I'm getting 0. On 225, I'm getting a +1. On 270, I'm getting an error. So an error means that's an asymptote. At 315, my calculator tells me -1. And at 360, my calculator is telling me it is 0. So drawing your tan graph, so you'll join your dots going up towards the asymptote and start to straighten up. Going from the middle dot, coming down, straighten up towards the asymptote. Remember, you can't touch the asymptote. And that is what your tan graph is going to look like. So do we know how to draw a tan graph now? Any questions? So drawing graphs are quite easy, good marks. Some things we need to know the tan graph. What is your period of the tan graph? Your period here is actually 180. Because from this asymptote at 90 to 270, your distance from here where you see an entire tan graph, 270 minus 90 is a distance of 180. So our period for the tan graph is 180. If they want to know what your range is minus infinity to infinity. Okay, so that's graph sketching. I want to quickly end with this question. Let's assume that, let's forget about what we drew now, but let's assume they gave us the graphs. So the first question is, what is the, it says sketch below are the graphs of f, 2 cos x, and g sine x minus 1. Now remember, it's different from the other one. The other one is minus sine x plus 1. The first question is, what is the period of f? Now f is a cos graph. Period of the cos graph is 360. What is the range of g? So if we want the range of g, we can look at the g graph. So the g graph, the lowest point here is sitting at 0. So not 0, that's your highest point. And your lowest point is sitting at -2 for the g graph. Okay. So therefore, our range for that graph is running from -2 to 0. So we're looking at the blue graph. And you can see your highest value is 0 and your lowest value is -2. They want the number of solutions that f of x is equal to. That means how many times do they meet in the graph that you're seeing? And if you want to work that out, they meet here and they meet here. So that answer would be 2. They meet 2 times. I'm going to jump to 5.3. The graph H is obtained by reflecting on the x-axis. Write down the coordinates of the minimum turning point of H in the interval. It's quite a toughie, right? So they're reflecting G. So let's look at the G graph. And let's start by saying, what is the minimum turning point of H at the moment on the G graph?
-2, sir.
The coordinates, all right? You've got to be careful there. It says the coordinates. What's your minimum TP on the coordinates of G as it stands right now? It'll be 270, am I right?
270,
-2.
-2, sir.
Right. But now we're reflecting on the x-axis. When we reflect on the x-axis, what are we actually doing to the equation? Sorry, they're calling it H. So our new equation here, if we reflect, we change the signs. That'll be minus sine x plus 1. Will we all agree with that? So if we reflect, then this will become your minimum, and that will become your maximum. So if we look at this reflecting, this point now will go to, the coordinate there is 90, and it'll go to 90 minus 2. So that would be our answer, 90 minus 2. That would be our minimum turning point. This now, when we reflect, becomes the maximum. And this will become the minimum. Are we in agreement there?
Yes, sir.
All right, gentlemen, I'm going to stop there now for today because it's nearly 8 o'clock. We will meet again tomorrow. Okay, so before I leave, are there any questions?
No, sir.
Sorry, sir. So for a cos graph,